What I can say is that I'm very thankful for the KCSAP scholarship, and this is because I was one among the self-sponsored students who benefited from the scholarship. I did a very wide project that consisted of 4 experiments, and one of those experiments was setting up field trials in Bomet, Nakuru, and Baringo counties. So I did 2 seasons in each site, and there I established a trial of 25 finger millet genotypes. And these 25 finger millet genotypes, they were those that were in the market and they were those that were still under trials. So the aim was to identify those finger millet varieties that were resistant to blast disease. And we chose finger millet because it is a resilient crop. And also these regions, likely like Baringo, it's somehow a semi-arid region. So we established these sites in order to identify the genotypes that can withstand both the environmental conditions and also those that can withstand the disease. I did a host plant resistance evaluation of these varieties, and later we did a field day in all the sites in order to teach farmers of these varieties. So the farmers were really impressed on the finger millet snapping varieties, because these varieties snaps, and it was a high yielding variety and it was resistant to blast, apart from it being snapping. So the snapping ability is the ability for it to break the stems instead of them using a knife to harvest the finger millet. So we did a field day, and this was because we need to bridge the gap between the scientists and farmers. We need to teach farmers of the innovations that we are upcoming with, we as scientists, so that it can be of impact to the community as well as to you as a scientist, so that you can mobilize the community, we can help increase productivity in those regions. One thing we are solving is the problem of sustainable production, sustainable agriculture. And sustainable agriculture, in this case, in my project, it was a farmer can be able to plant a variety of finger millet without necessarily having to spray, because once we have identified the resistant genotypes, a farmer can just go to the agrovet, buy the seed, and then once they buy the seed, then they can be able to plant it, and without so much worry of them losing their yield because of the disease. Another thing was the of sustainable production, the fact that this crop can survive in drought regions or semi-arid regions of Kenya. So in our trials, we did them in a place where less water is available. So the crop really survived well, and all the finger millet genotypes, this is just to prove that finger millet is a drought-resistant crop and it can survive in regions with less water. So for them, like now, the way there is less rain, this is a crop that can be planted, and this is a crop that a farmer can get a harvest by the end of the day. Now the farmers are able to know how to produce well, how can they survive during the short rains period, and how can they also get this highly nutritious crop. What I hope to see is more of this research getting out there. Yeah, whatever we are doing here in the labs, whatever we are doing to publish the big books, can it get out there and impact millions of farmers? Can we as scientists do practical things that can reach out to farmers and help them to obtain good and sustainable crops, and encourage the use of these scientific innovations out there in the field, so that the farmers can benefit from them. One of the experiments I did was field work, and the field work I did was in 3 sites. Yes, so in Baringo, Bomet, and Nakuru counties. And in these sites, we established field trials with the 25 varieties just to check the resistance of the disease in these 3 areas and how the finger millet responded to this. And we found out that some genotypes responded very well. They were resistant to the disease. and some were not, and some were moderately resistant. So for that, we recorded some genotypes for improvement, and some can be easily adopted by farmers right away. Yeah, from the field, we selected some of those genotypes and went and ran them in the greenhouse. So in the greenhouse, we evaluated 12 of the 25 varieties. And in these 12 varieties, we also identified those which had true resistance, and some which were moderately resistant, and some which were susceptible and moderately susceptible. Yeah. And from the greenhouse experiment, we had a discussion with my supervisor, and we thought it wise to do a lab experiment. And in this lab experiment, we sampled out blast disease from the 3 regions. And from these 3 regions, those blast disease, we isolated the pathogen, cultured it, and then after culturing the pathogen, we were able to sequence and to find out if indeed this is the pathogen that was causing that disease. I'm so thankful for the scholarship. That is one. I'm so thankful also to my supervisor, Professor Kimuto and Dr. Mafura. And I'm also thankful for Professor Woche, who was the one who really encouraged us to apply the scholarship. And what I would want to say is that KCSAP really provided us a light at the end of the tunnel, because some of us were in darkness, we didn't know how to pay our fees. But we are very thankful for the scholarship, and we wish also for others to benefit more. Yeah, you should come out and sponsor us even more to do our PhDs going forward.